Okay, hi everybody. So today we're going to start on series for the BC review. This is a 2020 version, so not everything on the series is going to be on there. So I'm only going to cover the things that are I deem to be important, or actually not me, that are going to actually be on the exam. Okay. So here we go. So actually, the first one is McLaurin. So, and it's still a little bit ambiguous of what's going to be actually on the exam because I know that there's going to be some things to do with Taylor series. My understanding is approximation, but they're not going to actually ask you to do anything with the expansion of Taylor. So, I still have to get more clarification on there. But we're going to go through some of these things, even though some of them may not be on there because I just don't know quite what's going to be on there yet. Okay, in its entirety. Okay, so function f is derivative of all orders, and it's given by this. Okay, here's the system that it's given us. The derivative of f satisfies the conditions above. The Maclaurin series of f converges for absolute value of x less than 1. Show that the first four non-zero terms of f are this, and write down the general term of Maclaurin series for f. Okay, so Maclaurin is, we have f of x. Remember, Maclaurin is centered around 0. So it is the zeroth derivative evaluated at 0, x to the power of 0 over 0 factorial, plus the first derivative evaluated at 0, x to the first, all over 1 factorial, plus the second derivative evaluated at 0, x squared, all over 2 factorial, plus all the way up. And you can see what the pattern is. And the last one, not the last one, but the nth term is going to be the nth derivative evaluated at 0, x to the power of n, all over n factorial. Okay, so that's the general term. Okay, so now all I have to do is utilize this. So if you notice, when it has a zeroth derivative, the zeroth derivative is actually the original f of 0. Okay, so that is the zeroth derivative. We also have the first derivative right there. So I need to calculate the second and the third. And it turns out I will need to calculate the fourth. Now, the reason why I'm going to calculate the fourth is because when you plug in the zeroth derivative for f, which is 0, that goes away. Okay, so I need to calculate the second, third, second, third, and the fourth derivative. Okay, so I'm going to go up here and let's go ahead and calculate these while we have it. Okay, so I'm going to go the second derivative of 0 by this definition. Now this is n plus 1 right here. Okay, it might be hard to see. This is n plus 1, so therefore n is equal to 1. So you're going to plug 1 there and 1 there. So this is going to be negative 1 times f of the first derivative evaluated at 0. Now, what is the first derivative evaluated at 0? It's 1. So this is negative 1 times 1 gives you negative 1. Okay, then let's calculate the third derivative evaluated at 0. So this is, if we're calculating the third derivative, that means n is going to be 2. So you have negative 2 times the second derivative evaluated at 0. Well, the second derivative evaluated at 0 is negative 1. So it's negative 2 times negative 1 gives you positive 2. Okay, let's go over here and do the fourth derivative then. The fourth derivative evaluated at 0 is, so that means n is 3 here. So this is negative 3 times the third derivative evaluated at 0. So it's negative 3 times 2, which gives you negative 6. Okay, so we have our derivatives. So then just have to plug it in here. So the first derivative evaluated at 0 is 1 times x all over 1, which gives me x, which is what I was trying to find. Okay, the next one, the second derivative evaluated at 0. The second derivative evaluated at 0 is negative 1. So this is minus 1 half, because 2 factorial is 2, x squared, which is the same thing as what you have there. Okay, the next one then, so the third derivative. So the third derivative is 2. So plus 2x squared. Let's see, I feel like I'm doing something wrong here. Third derivative, x cubed all over 3 factorial. That's what it was. Okay, and I'll reduce this in a minute. And then the last one is the fourth derivative. So minus 6x to the fourth all over 4 factorial. Now, this is not that, right? But what is 3 factorial? 3 factorial is 1 times 2 times 3. So the 2 is going to cancel the 1 times 2, and you're just left with 3. Okay, 4 factorial is 1 times 2 times 3 times 4. And what is 1 times 2 times 3? That's 6. So that's going to cancel that, and you're just left with the 4. So this gives you x minus x squared all over 2 plus x cubed all over 3 minus x to the 4th all over 4. Okay, and there it is. Okay, but we do have to write down the general term. I forgot about that. So writing down the general term. So what do we have? We have plus, minus. So we know that the general term, let's just go over here, is going to be -1 raised to some power. I'm going to leave it alone for the moment because I have to make sure it matches up. And then it goes x to the first, x squared, x cubed, and so on. So this is just x to the n. And then it's over 1. So this is just over n. Okay, because 1, 1, 2, 2, 3, 3, 4, 4. Okay, now, can I put n there? So if you think about this, when I plug in 1, I should get out this value. X to the first, that will work. Over 1, that will work. But -1 to the power of 1 is actually -1, but I need it to be +1. So I'm just going to put a +1 on there. And by putting a +1 on there, it just offsets it a little bit. So we'll go the correct plus minus. Okay, the next one, it converges absolutely, converges conditionally. We don't have to do that. That's not on the 2020 exam. Okay, so I'm going to skip over. Okay, write the first 4 non-zero terms in the general term in the Maclaurin series for this. Okay, so I just need to integrate this. So g of x is equal to the integral from 0 to x of f of t. Now, what is f of t, or what's the function f? The function f is given as this. So f of x is equal to this. So f of t is just this function, but with a bunch of t's in it. So it's t minus t squared all over 2 plus t cubed all over 3 minus t to the 4th all over 4 dt. So just integrate the individual pieces. So you have t squared all over 2 minus t cubed all over 6 plus t cubed to the 4th all over 12 minus t to the 5th all over 20. And this is evaluated from 0 to x. Okay, it's pretty clear to see when you plug in the 0, all this will go away. So just a matter of plug in the x. So x squared all over 2 minus x cubed all over 6 plus x to the 4th all over 12 plus x to the 5th all over 20. Okay, we also have to write the general term. Okay, so I'm going to go plus ... plus. Now, what is the general term? So you notice it goes x squared, x cubed, x to the 4th, and so on. So this is just going to be x to the power of n. And then on the bottom, this is kind of maybe difficult to see, but this is 1 times 2, this is 2 times 3, 3 times 4, 4 times 5, and then so on. So the bottom is just going to be n, and then n minus 1. Okay, and I'm going to have a plus or minus in here as well, so -1 to the power of n. Now, let's see if this is going to work, okay? So when we plug in a value for n, we should get this right here. Now, if you start off at 0, you're not going to get that because you're going to get x to the power of 0. So that doesn't work. But you can actually determine what you're going to plug in for this. So when I plug in, and this really depends on where you want to start. Is this the first term? Is it the 0th term? Could you start at the second term? Like, what exactly is this? It doesn't really matter as long as what value you plug in for n, it does match up here. Now, I'm just going to start with the first term. Okay, when I plug in 1, I should get out 2. That means that this is going to be a plus 1. Okay, so when I plug in 1, I should get 2. So it's going to be a plus 1. When I plug in 1, it's going to be 1. So this whole thing right here is just going to be n. And then when I plug in 1, it should be positive. Right now, when I plug in 1, it's going to be positive. So I'm going to make that a plus 1. Okay, so that right there is going to be the general term. Okay, the next one, airbound, you don't have to do. Okay, not going to be on the exam. Okay, number 2. Okay, so number 2 is basically the same type of a question. It gives you f1 is equal to 1, f prime of 1 is equal to -1/2, and it gives you the general formula here. Okay, now it's a Taylor series. I don't believe you need to know how to do this for the exam, but I'm going to use it later on. And so I'm just going to go through the process of doing this anyway. And I think it's good problem solving strategies and good thing to go over anyway. Okay. So Taylor series, where it's centered at 0, is you have f of x is equal to the zeroth derivative evaluated at where it is centered. It is centered at 1 here, times x minus where it's centered, 1, to the power of 0 all over 0 factorial. Okay, plus the first derivative evaluated at 1, x minus 1 to the power of 1 all over 1 factorial, plus the second derivative of 1 times x minus 1 squared all over 2 factorial, and then so on. Okay, that's the general formula. So I need to know what the zeroth derivative is. I do, it's right there. I need to know what the first derivative is, it's right there. But I need to do the first 4 terms, so I need to do second derivative and the third derivative. Okay, so the second derivative using this formula is f of 2 of 1 is equal to negative 1 squared times 2 minus 1 factorial all over 2 to the power of 2. So that is, this is 1. 2 minus 1 is 1. 1 factorial is 1 all over 4. So this is 1/4. Okay. Furthermore, I need to know what the third derivative is evaluated at 1. Well, that is negative 1 to the third all over 3 minus 1 factorial all over 2 to the power of 3. Okay, let's see if I have enough room. This is equal to negative, because that's a negative. This will be 2 factorial. So 2 factorial is 2 over 8. So 2 over 8 is going to give you negative 1/4. Okay, so let's go ahead and plug this in. So and this is approximately equal to. So that's equal to f0 of 1. Well, that's 1 times 1 times 1. So the first term is just 1. Okay, plus the first derivative is negative 1/2 times x minus 1 to the power of 1 all over 1 factorial. Okay, plus the next one, so the second derivative. The second derivative is equal to 1/4. So plus 1/4 times x minus 1 squared over 2 factorial. And they have to do one more. So the next one is negative 1/4, right? So plus a negative 1/4 x minus 1 cubed all over 3 factorial. Now, you're actually done. You don't need to go any further than this. Kind of. But I'm going to clean it up because it is nice to clean up a little bit. So I have 1. That's 1. So this is just minus 1/2 x minus 1. And then I have plus 1/8 times x minus 1 squared. And then I have minus 4 times 6. 4 times 6 is 24. So 1/24 x minus 1 cubed. Okay. Now, I also do need to include the general term there. How in the world are you going to do that? So the key to doing the general term is looking off of this formula. Okay, so the general term is going to be the nth derivative times x minus 1 to the power of n all over n factorial. That's what this is going to be. Now, we know what x minus 1 to the n power is and n factorial. I mean, I don't know what those are, but I can just leave this alone. What I don't know is that, but I do, because it's given by that formula. Okay, so the general term is going to be this. So you have negative 1 to the power of n times n minus 1 factorial all over 2 to the n. And then times, you have the rest of this. So you have x minus 1 to the power of n all over n factorial. Okay, plus, and that's the general term. Okay, so a little bit we can cancel here. Right here, n factorial, n minus 1 factorial. So all these are going to cancel all but just the n. So I'm left with 1 minus 1/2 x minus 1 plus 1/8 x minus 1 squared minus 1/24 x minus 1 cubed plus all the way out 2. And I have negative 1 to the power of n times x minus 1 to the power of n all over n times 2 to the n. Okay? And that's it. Okay, it's plus, it's a general term. Okay. Now this one is actually fairly simple if you look at it from the right perspective. So it does ask for a radius of convergence and an interval of convergence. Now, they did say that ratio test is going to be one of the things that's going to be on the exam, so we do know how to do the ratio test. Okay, you actually don't need to do the ratio test here. It's actually too much work. I'm going to do it both ways, though, so you can see what the ratio test is. The ratio test will tell us what the radius of convergence is, but hey, I already know what the radius of convergence is. It's 2. It's centered at 1. So what that means is it's centered at 1. If I go forward 2 or back 2, that is going to be the interval of convergence. Okay, so 2 up from 1 is 3. Oops, I'm just going to write less than x, and this should be less than 2 down from 1 is negative 1. Okay, now here's the thing. I need to check these endpoints because I need to know what the interval of convergence is, and it might be the possibility where those endpoints actually work. So how do you do it? Well, you plug it back into the formula. I don't have a formula right now, except for I do know what the general term is. So in other words, I could have written this summation up here as the summation of negative 1 to the power of n times x minus 1 to the power of n all over n times 2 to the power of n. Okay? I just need to know if it converges or not. Now there is a little caveat here I should talk about, and it has to do with the fact that this formula is only good for greater than or equal to 2. Okay? So this actually doesn't work when you plug in 0. It doesn't work when you plug in 1. It only works from there forward. Now, if you take out the 0 term and you take out the first term, that's not going to determine whether or not it's going to converge or diverge. It's the infinite amount of other terms that you add up after that. So in other words, I'm going to start this at 2 and I'm going to go up to infinity. It doesn't actually matter really for what I'm doing. Okay, so how do I check this? You plug in the endpoint. So I'm going to plug in the endpoint here, so negative 1. Okay, so I have the summation as n goes from 2 to infinity of negative 1 to the power of n times negative 1 minus 1 gives you negative 2 to the power of n, and all over n times 2 to the power of n. Now, this can be rewritten as a summation as n goes from 2 to infinity. Since that's the power of n and that's the power of n, I can actually combine those. So negative 1 times negative 2 is positive 2. So you have 2 to the power of the n on top times n times 2 to the power of n on the bottom. Those cancel, and you're just left with the summation as n goes from 2 to infinity of 1 over n, which we know diverges by p-series or harmonic. Okay, so that 1, negative 1 cannot be included. Let's check the 3. Okay, so checking the 3 now. You plug it back into this equation. So you have the sum as n goes from 2 to infinity of negative 1 to the power of n. 3 minus 1 is 2, so you have 2 to the power of n all over n times 2 to the power of n. Those cancel, and you're left with the summation as n goes from 2 to infinity of negative 1 to the power of n all over n. So does this converge? Okay, so what has been told to me by the AP is that you only need to know a few different things about series. Geometric, P-series or harmonic, and the last one is AST, the alternating series test. Hopefully you see this is the alternating series test. Why is it alternating? Because it goes plus or minus because it's negative 1 to the power of n. So alternating series test, what are the things you need to check for? Okay, so I'm going to ignore the negative 1. I'm just going to look at 1 over n. Is it always going to be positive? Check. Okay, it will always be positive. Is it decreasing? As n gets bigger and bigger and bigger, does 1 over n decrease? Absolutely. And the last thing you need to check is, does the limit as n goes to infinity of 1 over n go to 0? And yes, it does. Okay, so 1 over n is greater than 0. 1 over n is decreasing. You don't have to write this out. I'm just writing this out so you guys can see. And then the limit as n goes to infinity of 1 over n does equal to 0. Okay, so by AST, this converges, which means when you plug in 3, it works. That means the interval convergence should be that. Okay? Kind of cool question. I said I was going to do the ratio test. I'm not doing it, but make sure you know how to do it. Okay, we will have to do this in a little bit. Okay, C. Okay, the Taylor series for f about x equal to 1 can be used to represent f of 1.2 as an alternating series. Use the first 3 non-zero terms of the alternating series to approximate this. Okay, from what I've been told, this is the one portion of Taylor series you'll have to use is plugging in the value to estimate it. So I know f of x is approximately equal to, what do we come up with? I think we came up with this. Now we're only supposed to use the first 3 terms, so I'm only going to use those. So this is 1 minus 1/2 x minus 1 plus 1/8 x minus 1 squared. So f of 1.2 is approximately equal to 1 minus 1/2 times 1.2 minus 1 plus 1/8 times 1.2 minus 1 squared. Be done. Okay, by AP, they say all you have to do is show that you know how to do it. You don't actually have to go through and do the arithmetic to actually come up with the answer. You can leave your answers unsimplified. There you are. Okay, but I want to figure out what it's equal to. Okay, like I said, don't do this, but I want to do it anyway. So 1 minus 1.2 minus 1 is 0.2. So 0.2 over 2 plus 0.2 minus 1 is 0.2. 0.2 squared is 0.04 all over 8. So this is equal to 1 minus 0.1 plus 0.005. So 1 minus 0.1 is 0.9. So this is equal to 0.905. Okay, and that's an error question, so we don't have to do that one. Okay, on to 3. Okay, use the ratio test. Here we are. Okay, so now here's my summation right here, and I have to use the ratio test. Now remember the ratio test. What I want to do is I want to take the limit as n goes to infinity of a of n plus 1 all over a of n, and I want this to be less than 1. Okay, that's what I want to show. So if this thing right here, put this in a circle. Oops, that should include that. That's a of n. So a of n plus 1 is just plugging in n plus 1 there. So we have the limit as n goes to infinity of a of n plus 1. So everywhere there's an n, I'm going to place an n plus 1. So I have negative 3 to the n plus 1 minus 1. Well, that's just n times x to the n plus 1 all over n plus 1. Now you're supposed to divide through by a to the n, and I am, but I'm just going to skip that step. I'm going to flip and I'm going to multiply. So this is times this thing, but inverted. So there's only n on the top. I have negative 3 to the n minus 1, and then x to the n on the bottom. This is just separating the two. Okay, sorry. Okay, so this is equal then to the limit as n goes to infinity of. So what are some things that can cancel? You have n negative 3's on the top, n minus 1 negative 3's on the bottom. So you have one more on the bottom. You have one more on the top than you do the bottom. So this is going to cancel everything but that. This has nothing to do with an n anymore, so I'm going to bring it out, but I'm going to take the absolute value of it. So there's a 3 there. Okay, furthermore, there's n x's here, there's n plus 1 x's there, so these n are going to cancel all but one of those, so there's going to be an absolute value of x on the outside there. And I'm left with n all over n plus 1. Well, what is that? 3 times the absolute value of x times the limit of this, both the first power, so you take the leading coefficients, 1 over 1 is 1, and there you are. Now, if this is the ratio test, I want it to be less than 1. So therefore, the absolute value of x is less than 1/3. Now, what do I need to know? I need to know what the radius of convergence is only. That's all I need to do. So there it is. We're 1/3. That's what the radius of convergence is equal to. Now, just to get some extra practice in, I'm going to come up with the interval of convergence. Okay, so interval of convergence. So based off of this right here, I'm going to rewrite this as negative 1/3 is less than x, which is less than 1/3. And now I need to check the negative 1/3 and the positive 1/3. So I have to take this, plug it back into the general equation. So doing so, I have the summation as n goes from 1 to infinity of negative 3 to the n minus 1 power times x. Now I'm checking this. This is my x. So I have negative 1/3 to the n power all over n. Okay, now you notice these are really similar, right? You have 3 and then negative 1/3. You can see that. But the problem is this is the n and this is n minus 1 and that is n. So I'm going to do 1/3 over here in a minute. Okay, so I have the sum as n goes from 1 to infinity of negative 3. What am I doing? Negative 3 to the n minus 1 power. Now this is a trick. I'm going to combine those, but I can't. This should be n, right? This should be n. I can't combine those because those are off by 1. So separate it. I'm going to rewrite this as negative 1/3 to the n minus 1 times negative 1/3 to the first power all over n. All I did is I took this right here, negative 1/3 to the power of n, and I split it apart. Okay, now why did I do that? Because now this is n minus 1 and that is n minus 1, so I can just combine those two. Okay, so this gives me the summation. This is negative 1/3, so I'm going to bring it out in front. And then this right here is negative 3 times negative 1/3 is just positive 1. So that's just 1 over n. And this diverges. Okay, by p series or harmonic. So in other words, this negative 1/3 is not included. Now over here for 1/3, so this is x is equal to negative 1/3. So this is going to be x is equal to 1/3. So I essentially do the same exact thing. So I have the sum as n goes from 1 to infinity of negative 3 to the n minus 1 times 1/3 to the power of n. So this is a sum as n goes from 1 to infinity of negative 3 to the n minus 1 times 1/3 to the n minus 1 times 1/3 all over n. Bring it out. Now, so I have 1/3 times the sum as n goes from 1 to infinity. Negative 3 times 1/3, that is negative 1. So this is going to be negative 1 to the n minus 1 power all over n. And hopefully you see this is going to converge by AST, alternating series test. 1 over n is positive. It's decreasing. The limit as n goes to infinity is 0. So this converges. Okay, so there should be an inequality there, and that is the interval of convergence. Once again, this bottom portion you actually didn't need to do, but I wanted to go through it just so you could refresh your memory of how to get it done. Okay, the next one, write the first 4 non-zero terms of the Maclaurin series f prime, the derivative f, express f as a rational function. Okay, so f is given as this up here. Okay, so I have x minus 3/2. So x minus 3/2 x squared. This is a f of x's. And then plus 3x cubed plus dot, 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 plus. So it's alternating. So negative 3 to the n minus 1. X to the n all over. Did I preemptively put that? No, I'm good. Okay, so there we are. So then the first derivative of f is equal to 1 minus 3x plus 9x squared plus, don't know, plus, and then the last one, this right here is just a constant, right? We're taking the derivative with respect to x. That's the only thing with an x in it. So bring it down. The n's cancel. And so you're left with negative 3 to the n minus 1 times x to the n minus 1. Okay, because the n's canceled. Now it said I need to write the first 4 non-zero terms. So I need one more in here. So how do I get that one more? Well, you have a general term equation. So this is x to the n, which is 3, but I need the next one, so 4. So the next one, f prime of x is equal to 1 minus 3x plus 9x squared. And then, so you're going to plug in 4 here, right? So you have negative 3 to the 4 minus 1. So that's negative 3 cubed. So this is negative 27 all over x to the 4th all over 4. And that's it. Okay, there we are. Okay. Now, I'm pretty sure you don't have to do this next one, but once again, I'm not entirely sure, so I am going to go over it anyway. Okay, right. The first 4 non-zero terms of the Maclaurin series for e to the x, you should know that. 1 plus x squared all over 2 factorial plus x cubed all over 3 factorial. Okay, you should know that. Okay, use the Maclaurin series for e to the x to write a third degree Taylor polynomial for this. So g of x is equal to e to the x, which is this, 1 plus x squared all over 2 factorial plus x cubed all over 3 factorial plus, actually, that's it, and then times f of x, which is given by this. So 1 minus 3x plus 9x squared minus 27x to the 4th all over 4. Now I need a third degree Taylor polynomial, so I'm only going to go up to degree 3. Okay, which means Is that right? Yeah. Which means I don't need this last one. There's no way I can take something times the fourth power and have it turn into a third power in between these two. Okay. So I need to come up with the constants. Okay. So constants. The only way I can get a constant is 1 times 1. So I'm done. Okay. Now, how am I going to get an x term? I'm going to get an x term by taking x times 1. And there's nothing else I can multiply here other than 1 times negative 3x, which is negative 3x. Okay. Now let's do the x squared. How do I get an x squared? To get an x squared, you take 1 times 9x squared plus x times negative 3x, so minus 3x squared. And then the last way, did I do that right? X. So 1, so I'm dealing with the squared, and then that times that. Yeah, so that's good. And then the last thing I do is take this times the 1 to get plus x squared all over 2 factorial. Okay, so I've gone ahead and take these things times that to get the x squared. Okay, is there anything we can do going backwards then? There shouldn't be. Okay, 1 times x squared, which is I already have. Yeah, so that's it. Okay, then I need to do the x cubed. So how do I do an x cubed? Am I missing a term here? Let's see, did I take the derivative right? Oh, I never took the derivative of this, did I? Shoot. This is the term, I need to take the derivative of it. So I bring down the 4, the 4s will cancel, and I'm left with that. Okay, so this is actually negative 27x cubed. Okay, sorry about that. I don't think it changes any of your answer yet because I don't think we've used it yet. Okay, now how do we get x cubed? I'm going to take 1 times that, so minus 27x cubed. X times the x squared, so plus 9x cubed. X squared times the x, so minus 3x cubed all over 2 factorial. And then that times the 1, so plus x cubed all over 3 factorial. Okay, and then basically we can be done. Okay, we don't need to go any further, but let's clean it up anyway. So 1 plus, or actually minus 2x. And then here are the 3 x squared. So this is going to be 6 plus a half. So what is that? So 6 is the same thing as 12 all over 2. That's plus 1 over 2. So this is plus 13 halves x squared. Okay, and then here we have to do this. Yeah, this is like too much work for me. It's not that bad. So negative 27 plus 9 is what? Negative 18. Is that right? And then minus 3x cubed all over 2 plus x cubed all over 6. So x cubed. So I have negative 18x cubed minus 9x cubed all over 6 plus x squared over 6. So negative 18x cubed minus 8x cubed all over 6. So negative 18x cubed minus 4x cubed all over 3. So negative 54x cubed all over 3 minus 4x cubed all over 3, which gives you negative 58x cubed all over 3. I guarantee I made a mistake in there somewhere. Okay, I leave you guys to figure out what it is. I'm sure I made an arithmetic error in there somewhere. Okay, anyway, I'm not going to spend any more time on it because I don't need to cover the rest of the stuff. Okay, and that is it. Okay, number 4. Okay, we got 2 left. See if we can't crank through this. Okay, find the value of r. So radius of convergence. So I'm going to take the limit as n goes to infinity of the absolute value of negative 1 to the n plus 2 power times 2 to the n plus 1 power times x minus 1 to the n plus 1 power all over n plus 1. Sorry, I should times this. That shouldn't be there. Okay, then I just have to rewrite this, but everything gets flipped. So now I have n on the top, and on the bottom I have negative 1 to the n plus 1, 2 to the n on the bottom, and then x minus 1 to the power of n there. Okay, once again, that's not supposed to be there. Okay, so start canceling some things. You have one more 2 on the top than the bottom. I'm going to bring it out. The negative 1s I can get rid of because I'm taking the absolute value of it. And then here I have 1 n plus 1. I have one more x minus 1 on the top than the bottom. So all those are going to cancel all but one of those, and I'm just left with the absolute value of x minus 1, which I can bring out front, and I can bring out front because there's nothing to do with an n there. I'm taking the limit. And then this is going to be n all over n plus 1. Okay, this limit we know goes to 1, so this is 2 times the absolute value of x minus 1. In order for it to converge, I need it to be less than 1. So I have x minus 1 is less than 1/2. There is going to be my radius of convergence right there. Okay, 1/2. Okay, if you don't believe me, I can go a little bit further. So I have negative 1/2 is less than x minus 1, which is less than positive 1/2. Add 1, so you have 1/2 is less than x, which is less than 3/2. And so you can see the total distance there between those two is 1, so and half gives you 1/2. Okay, next one. Find the first 3 non-zero terms in the general term of the Taylor series for the derivative of about 1, okay? So all I need to do is go back here and take the derivative. Now, I'm doing the first 3 terms, so let me go ahead and write out what the first 3 terms would be, and then take the derivative. That's one way you can do it. And I think that might... Actually, no. Let's go and take the derivative of this, just so we practice this. Okay, so f of x is equal to the summation as n goes from 1 to infinity of negative 1 to the n plus 1 times 2 to the n all over n times x minus 1 to the power of n. So the derivative here is equal to, well, the only thing with an x here is that. So everything else is just a constant. So this is the integral, the summation as n goes from 1 to infinity of negative 1 to the n plus 1, 2 to the n, bring down the n's, but those are going to cancel. So you have x minus 1 to the n minus 1 power. Okay, so there it is. I need the first 3 non-zero terms. So I plug in 1. When I plug in 1, oh, this is for n though. When I plug in 1, so this is going to be positive 1, 2 times x minus 1 to the power of 0. Okay, plus plug in 2, so this would be negative 1 times 2 squared times x minus 1 to the first power. Okay, plug in, so plug in 1, 2, 3. So that'll be positive 1. So this will be 2 to the power of 3 times x minus 1 to the power of 2. So this is 2 minus 4 times x minus 1 plus 8 times x minus 1 squared. Okay. The general term, by the way, I've actually already found. It's right there. Okay. Now, the last one's kind of unique, okay? And I think it's worth going over because it does talk about it being a geometric, okay? It is geometric there. So, so this right here is a geometric series. Find the function f prime to which the series converges for this. Okay. So what is a geometric series? A geometric series is you have some sort of ratio. What's less than, if that ratio is less than 1, then it's going to converge. If it's greater than 1, it's going to diverge. So let's clean this up a little bit. So f prime of x is equal to the summation as n goes from 1 to infinity. Now I'm going to try and get all these in the same term. So you notice the lowest one is n minus 1. So I'm going to change all of these to n minus 1. Now you notice this. If I switch this to an n minus 1, that means I'm going down 2 steps, right? I'm going from n plus 1 to n minus 1. That's 2 steps. So in other words, it's like taking out a negative 1 squared. But a negative 1 squared is just positive 1. That is probably really confusing. Sorry. So that's the same thing as negative 1 to the n minus 1. Times 2 to the n minus 1 times 2 times x minus 1 to the power of n minus 1. So now this is a 2, so just bring the 2 out in front. So I have n is equal to 1 to infinity of, and let's combine everything else. So I'm going to have negative 2 times x minus 1 all to the power of n minus 1. So this is 2 times the summation as n goes from 1 to infinity of, so going to distribute negative 2 times negative 1 gives you 2, minus 2x raised to the power of n minus 1. Oops, sorry, can't even see that. Okay, so this is going to be geometric. And I know it's hard to see because usually you see geometric as like a ratio of fractions. So this thing's a fraction. But I don't care that this doesn't look like a fraction. I just want it to be less than 1. I want the absolute value of it to be less than 1. So what I know is the absolute value of 2 minus 2x, in order for it to converge, has to be less than 1. So I have negative 1 is less than 2 minus 2x, which is less than 1. Subtract over the 2, so negative 3 is less than negative 2x, which is less than negative 1. Divide through everything by a negative 2. So I have 3 halves is greater than x, which is greater than 1 half. Okay? So find the function f prime, which the series converges. Use this information to determine f for this. Okay? So I know that it's going to end up converging between those two. Okay? Anyway, that's all I'm going to spend time on that because I just wanted to deal with the geometric and how to change it into geometric. Okay, and last one. Okay, number 5. Function f has derivatives of all orders at x equal to 0. Let p of n, so that's the polynomial of degree n, denote the nth degree Taylor polynomial about x is equal to 0. It is known that f of 0 is equal to negative 4th, and the first degree polynomial evaluated at 1/2 is equal to negative 3. Show that f prime of 0 is equal to 2. Holy schmolies. How in the world do we do this? So it's a Taylor polynomial about x equals 0. So that's really Maclaurin, right? So how do you do Maclaurin? So you have f of x is equal to the 0th derivative evaluated at 0, x to the power of 0 over 0 factorial, plus the first derivative evaluated at 0, x to the first power all over 1 factorial, plus the second derivative evaluated at 0, x squared all over 2 factorial, and then so on. But I'm going to utilize this right there. That's the first degree Taylor polynomial. So this isn't even included. So I know when I have this function and I plug in 1/2, I should get out negative 3. So let's evaluate it. Okay, so I'm going to get out negative 3 is equal to, now the original function evaluated at 0 is just negative 4. And that's 1, that's 1. Okay, plus the first derivative evaluated at 0, well, look, it's 2. So 2 times, oh, actually, no, that's what I'm trying to show. I'm trying to show that it is. So this is f prime of 0. And then we're evaluating it 1/2. So times 1/2. Okay, add it over. So you have 1 is equal to 1/2 f prime of 0 multiplied by 2. 2 is equal to f prime of 0. Okay, kind of clever manipulation. Okay, it is known that this is that and that's that. Find the third degree. So let's basically duplicate what we have. So I have this right here, but now I'm going up to the third degree. So I have f of x is equal to the 0th derivative evaluated at 0 over 0 factorial x to the power of 0 plus the first derivative evaluated at 0 x to the first all over 1 factorial plus the second derivative evaluated at 0 x squared all over 2 factorial plus the third derivative evaluated at 0 x cubed all over 3 factorial. Okay, so now we're just going to plug in everything. Okay, so because that's what I'm trying to find. I'm trying to find the third degree polynomial, which is this. Okay, so this is P3 of x. Okay, so this is equal to the 0th value evaluated at 0, so that's negative 4. So this whole entire thing is just negative 4, plus the first derivative value at 0, which is 2 from we found before, times x, plus the second derivative value at 0 right here, so negative 2/3 x squared all over 2. And then plus the third derivative, which is 1/3, x cubed all over 3 factorial. And I'm done. I'm going to clean it up, though, just because that's how I am. So this is going to be negative 1/3 x squared. Okay, that's a 6. 2 is on the top. So 2 divided by 6 is 3. And then this is going to be 6 times 3. So plus 1/18 x cubed. Okay, so right there. Okay. So the function h has a first derivative given by h prime is equal to that. Okay, it is known that h of 0 is equal to that. Find the third degree Taylor polynomial for h. So we have h of x is going to be equal to so you have the 0th derivative evaluated at 0, x to the power of 0 over 0 factorial, plus h prime of 0, x to the first all over 1 factorial, plus h double prime of 0, x squared all over 2 factorial. I need third degree, so plus h triple prime of 0, x cubed all over 3 factorial. So what is this equal to? Okay, so h of 0 is 7. So this is 7. Everything else is 1, so that's 7. Plus the first derivative evaluated at 0. Well, the first derivative evaluated at 0 from up here, let me go down here a little bit. So h prime of 0 is equal to f of, well, 0. And what is f of 0? Turn it back to the other side. F of 0 is negative 4. So this is h prime of 0 is negative 4. So this is minus 4x plus the second derivative. So the second derivative, take the derivative up here. So h double prime of x is equal to f prime of 2x. But by the chain rule, you have to multiply by the derivative side, which is 2. So I have h double prime of 0 is equal to 2 times f prime of 0. What is f prime of 0? F prime of 0 is 2. So this is 2 times 2, so that's going to give you 4. So plus 4x squared all over 2. Okay, and then I just have to do the third derivative. Okay, so h triple prime of x is equal to, so here is the second derivative right here. So the third derivative is going to be 4 times f double prime of 2x. Where'd the 4 come from? When you take the derivative of this, by the chain rule, it's going to pop out. So 2 times the 2 is going to give you the 4. So h triple prime of 0 is equal to 4 times f triple prime of 0, double prime, right? Double prime, sorry. So what is f double prime of 0? F double prime of 0 is negative 2/3. So I have 4 times negative 2/3, which is equal to negative 8/3. So I'm going to have minus 8/3 x cubed all over 3 factorial. So this is 7 minus 4x plus 2x squared. So this is 6. And so 6 times 3 is going to give you 18. 6 times 3 is going to give you 18. 8 on the top, so 4/9. So minus 4/9 x cubed. And there we are. Okay, hope you guys had fun with that. I know I did. Okay, so I will see you next time. Bye, everybody.